All right, we're going to start page 3 of our semester review. Page 3 is graphing. So we have something in slope-intercept form. Remember, this number that's by itself is the y-intercept, so I'm going to put a dot at y equals 3. And from that point, I'm going to move the slope rise over run up 1 over 4. So up 1 over 4. If I can no longer go up and to the right, I'm going to go down and to the left, which is the same slope. And then you take your handy-dandy straight edge and connect. Question number 2. We have the y-intercept of 1. Put a dot there. We have a slope of negative 1. There's always a 1 there, which is negative 1 over 1. So I'm going to go down 1 to the right 1, down 1 to the right 1. If I run out of down and to the rights, I can go up and to the left. Connect those dots, and there's your graph for number 2. Number 3 is in standard form, so I'm going to make my little table with my x and y intercepts. If x is equal to 0, I get 3y equals 6, divide by 3, divide by 3, I get y equals 2. And if my y is equal to 0, I get x equals 6. Graphing those 2 points, I get 0, 2 is right there, 6, 0, 1, 2, 3, 4, 5, 6, 0. And then we play dot to dot. And there's the graph for number 3. Question number 4, we have a inequality, so we have one extra step of shading on this one, but the graph to start with is the same. Y-intercept of negative 1, slope of 1, so up 1 over 1, up 1 over 1. Because of the equal sign, it's going to be a solid line, and it's going to look like that. Then to test to see which side we shade, if I test the point 0, 0, I get 0 is greater than or equal to 0 minus 1, which is true. 0 is greater than negative 1, so on the side with 0, 0, I'm going to shade. Question number 5. The y-intercept of 5, 1, 2, 3, 4, 5. Slope of negative 2, that's negative 2 over 1, so I'm going to go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. Since there's no equal sign there, I know that this graph is going to be a dotted line. And again, since it's an inequality, we have to decide which side we're going to shade. So I'm going to test the point 0, 0. 0 is less than negative 2 times 0 plus 5. Is 0 less than negative 5, positive 5? Yes, it is. So I'm going to shade on the side where it was true. In question number 6, we have 2 inequalities, and we're going to shade both of them. Here we have y is less than 2. We know that that is a horizontal line at 2, and it's going to be a dotted line. And since it's greater than, we would shade above the line. So I'm going to put these little arrows in here to indicate that I'm shading above the line. The second equation has a y inequality, has a y-intercept of 1 and a slope of 2/3. So I'm going to go up 2 over 3, and I get that point. If I can't go up and to the right anymore, I'm going to go down 2 to the left 3. And this one again is a dotted line, so I'm going to make that look like that. And we're going to test a point. 0, 0 is below the line. Testing that point, I get 0 is greater than 2/3 times 0 plus 1. 0 is greater than 1. That's a false statement at 0, 0. So it will be true on the other side. The double shaded region is in here. For question number 7, y is less than 4. Again, y is a horizontal line, 1, 2, 3, 4. Solid line because of the equal sign, and I'm going to shade below it. The second inequality is x is greater than 1, which is a vertical line at 1. and it's a solid line, and greater than would be that direction, so we're going to shade that whole region. On the bottom, we have graph the compound inequality on a number line, and then write the interval notation. If I have x is greater than 4, would look like that. X is less than or equal to 9, would look like that. Since it's an and statement, it's what's between them, so I'm going to write it in interval notation as the inclusive 9 and the non-inclusive 4. Over here, we're going to solve these. I get x is greater than 5, or adding 7, I get 2x is less than or equal to negative 6, x is less than or equal to negative 3. On a number line, that would look like, here's my negative 3. We're going less than or equal to, so that's going to be a bracket going to the left. X is greater than 5, parenthesis going to the right. Since it's an or statement, we would have a compound statement, which would be from negative infinity to negative 3 inclusive, union 5 to infinity.